performing ISIS routing operation. The OSI layer addressing is implemented with NSAP addresses. See, that is the early story. Network layer address was not IP address, it was NSAP, which is nothing but CLNS. The NSAP address identifies system in the OSI. You remember I was typing one net ID. That is what NSAP means. You remember this one, which I explained when I was doing the lab. Yeah, you see this. You remember these things?
Yeah. NET.
The command is NET to configure. The command is NET. Okay, NET, net address. So we are going to learn about that today's class. The NSAP address identifies a system. So it's like a router ID in OSPF. OSPF router ID is what used in network layer for OSPF devices. For ISIS running devices, it uses NSAP address to identify the router. That is what system here means. A system means a router here. The system that runs ISIS is a system. For us, it's a router in OSI network. An address represented as entire node, not the interface. So the router ID is for the router. It's not for particular interface. That's why I said it is like a router ID. It is not for one interface, it's for the entire router. The address that is used to identify the entire router in CLNS network is NSAP address. Various NSAP formats are used in various systems. I told you ISIS is not only used by IP, it is used even in layer 2 technology. So every technology that uses ISIS may not be having same NSAP address format. It will differ. I have seen like 3 different ISIS implementation other than IP. Other than IP, I have seen ISIS used in a protocol called what is that? Okay, the one is OTV. There's a concept called OTV uses ISIS. Another one is fabric path. So ISIS is also used in a layer 2 level. Those devices, those concepts like fabric path, OTV, CLNS, they may not use the same NSAP format. This is a format for IP version of ISIS. Various NSAP formats are used in various systems because different protocol may use different representation of NSAP. NSAP addresses are maximum of 20 bytes. You remember in our previous lab demo class, I said this is called N selector.
Yes.
N selector is 1 byte. And then you will have 6 bytes of system ID. So totally 7 is over. The remaining 13 bytes is what area. But in our example previously, when we did the lab, we use area only 2 bytes. But you can even have up to 13 bytes. which includes that 49, which is private area. Yeah. So totally 20 bytes. That's the max. The higher order bits identifies the inter-area structure, meaning the higher order means these bits are, this higher order 13 bits are area IDs. The lower order bits identifies the system within a area. So this is to identify the system within this area, which is mentioned in the higher order bit. So this NSAP address is of two main separations. So two main sections. One is the area portion. The other one is the system portion. The higher order 13 bit is area, but it need not to be 13 bit. It can be anything between 2 bytes to 13 bytes, not bytes. It can be anything between 2 to 13 bytes area ID. Whereas system ID should be 6 bytes plus N selector 00 represents that this is the IP version of ISIS. So this is what we are going to see here in depth. The integration of ISIS NSAP address structure. N selector 1 byte. System ID 6 byte. And then the higher order bits, they have granularly divided again into 3 sections, but this variable length address, area address, can be between 2 to 13 bytes. These subdivisions are not really in use today. We just see all this as a area address. These divisions are not really in use. They have some subdivisions inside the area portion, but we don't use it. We don't use them. Let's see what they are. The Cisco implementation of integrated ISIS distinguishes only the following 3 fields. See, I told you, only 3 fields. Area address. It can be between 1 byte to 13 bytes. This one. And then system ID, which is 6 bytes. Bytes are octet, both are same. And then N selector, only 1 byte. This is the actual classification. So this AFI, IDI, IDP, you don't need to worry about those things. We don't care about those things. Now, the total length of NSAP is from, see, this is 6, this is 7, and the area ID is minimum 1. Minimum 1. So totally, it can be from minimum of 8 byte to 20 byte. Byte or octet, both are same, isn't it? Byte is 8 bit.
8 bits.
Yeah. So area ID can be between 1 to 13 bytes. If it is only 1 byte, then the total length is going to be 8. If you use all 13 bytes of area, then it is going to be 20. And NSAP address will be 20 if you use all 13 octets of area. Typical NSAP address structure. The simplest NSAP format used by most companies running ISIS as the IGP. I told you this number 49 is for IGP. Mostly people use ISIS as IGP protocol, not EGP, not between the borders. So to represent that IGP, but it is not mandatory, but just to represent, we always put 49. That is what this 40 AFI means. 49. The locally administrated, thus you can assign your own address. So 49, and then you can put your own area ID, system ID, and selector ID. Next, what is the area ID? Area ID is the octates, which can be between 1 to 13, including AFI, which comes immediately after AFI. All right, so immediately after AFI comes the area ID. So don't worry about this IDI and all. Not relevant now. Okay, next is system ID. Cisco routers need 6 bytes of system ID. So for this, what some people will do, they will take the MAC address and they will put it there. Some people will put the loopback address with some additional zeros because the size of IPv4 is only 32 bit. But what is the size of the system ID? It is 48 bit, no? Because 6 bytes. 6 fours are 24. 24. No, 6 eights are 8, 6 are 48. So some people used to take the IP address, 32-bit IP address, and add some 0 to make it as 6 bytes. It's 32-bit address. But you saw me using like this. I just put 00. See, someone has taken the MAC address and they have inserted as a system ID. But you saw me doing like 000000000001 and like this 2, 3, 4, like this. So N selector always set to 0. Now, how the systems are identified? They are identified first with the area, and inside the area, every device will have a unique system ID. So if you see this blue portion, it is same on every router because it's an area ID. This is area 4. This is matching on every router, but this portion is unique. Here it is 88888. Here it is 99999222222. The area address uniquely identifies the routing area, and the system ID identifies each node. So it is the area ID defines the boundary. Which router is in what area is identified using area ID. Inside the area ID, you have a system ID to differentiate one device from the other within an area. All the routers within an area must use same area address. That's what we saw, 49.001. Same on every router in that area 1. See, when you do the lab, you need to keep all these things in mind. Next. And ES, what is ES? End system. But those things are not needed. What does that end system means? It means computer. A computer may share this, but the computer should be part of CLNS. Only they use this. But we don't have CLNS, so don't need to worry about this. And ES may be adjacent to the router. What does that ES means? Computer. End system. Maybe adjacent to the router only if they share a common address. Don't worry about this point, not needed. Next. Area addresses is used in level 2 routing, meaning between different routers inside the same area, area ID is not used. What is used? The system ID is used to identify. Yes or no? Yeah. Whereas between the routers of different area, they don't care about the system ID. They focus on what? The area ID.
Okay.
Yeah, so that's what the area address is used in level 2 routing, meaning between the area routing. That is what called as level 2 routing. What is level 1 routing?
What is level?
1 routing.
That is within area.
Correct. Very well said. Within an area. Next. Identifying systems in ISIS. So here they are talking about the system ID. So this all routers are in same area, 4900AA. System ID is an address used to identify the intermediate system, meaning router. It is not just an interface. Cisco supports only 6 bytes of system ID. System ID is used in level 1 routing. Correct, no? We spoke about
Yes.
this already.
Yes.
System ID is unique within an area. System ID has unique within system ID has to be unique within level 2 router. So it's same rule. It needs to be unique within an area. It also needs to be within a L2 router. Next, the general recommendation. Use a domain wide unique system ID. So what they are saying is not only within an area, throughout the ISIS domain, try to use only the unique system ID. Don't give the same system ID to two different router when they are in different area. You understand what I'm saying? Sometimes when you give same system ID to two routers, thinking that okay they are in different area, not all the time it will cause problem, but sometime it will cause problem. Conflicting. So here they are giving you example how to use a MAC address, because when you use MAC address of a device or an interface, it is going to be a unique system ID. Correct, no? MAC address, the size of MAC address is 48 bit. The system ID is also how much? 48 bit. You can also take an IP address, see 192.168, they put some extra zeros and made it as an IP address. So you may use an IP address or a MAC address taken from an interface so that the system ID of the NSAP, the system ID of NSAP will be unique. Now, net address. NSAP address includes N selector. What is N selector? The last zero, which is always 0 for IP. So NSAP address includes N selector. Net colon NSAP with N selector field of 0. So what is net? Net is NSAP and N selector. Refers to the device itself. Equivalent to layer 3 of OSI address. Means NSAP or net ID is nothing but the router ID. Used in the router because they implement the network layer only based on the shortest path first. So see, this is not a layer 4 protocol. In layer 4 protocol, you have TCP, you have UDP to provide reliability. Because this is working in layer 3 level, there is need for some IDs. That's why they use what? N selector, NSAP. NSAP. See, here they're using N selector as 01 because it is going via some frame relay, old concept. They'll see. Let's read. Subnetwork point of attachment, NSAP, sorry, SNAP, SPAN, and circuit. SNPA is equivalent to layer 2 address, for example, virtual router ID, they'll see on frame relay, MAC address on LAN interface. Simple, what they are saying is that 6-byte system ID is what called as SNPA. This SNPA can be a MAC address, can also be an IP address. That's what we saw in the previous chapter, previous page here. If it is frame relay, they're comparing, I don't know whether you know frame relay or not, which is old technology. They're comparing the SNPA to a layer 2 addresses. MAC address is an example for layer 2 address in LAN. VCID or virtual circuit ID, which is called as DELC, data link connection identifier. Data link connection identifier. That is again layer 2 address in MAC in frame relay. So here they are comparing the NSAP to a layer 2 addresses. Interface uniquely identifies interfaces uniquely identified by circuit ID. Every single interface is one circuit ID. On a point-to-point interface, SNPA is used. On a LAN, the circuit ID is used. Circuit ID is 6 octet system ID. So it uses the system ID plus the circuit number here to distinguish the. So there will be 7 octets now. 6 octet of system ID plus the 7th one will be the circuit ID if it is LAN. If it is point to point, there is no need for circuit ID. Whereas in LAN, it is going to use N selector as circuit ID. I'll show you in the command line when I type show ISIS neighbor, you will see that circuit ID. You may remember it. I showed you the previous class in the demo, or I'll show you in the coming demos. In the neighbor command, you will see the circuit ID. I was showing 2 commands for the neighbor. One is show CLNS neighbor. There also they showed the circuit ID. Cisco routers use host name instead of system ID. In the output, they are talking in the output. I remember I showed you when I was showing neighbor, there was router name reflecting, the name of the neighbor router. It was reflecting. If you go back to the previous class video also, you can see that. Fine. So far what we saw is about the NSAP address or the net address. Now this is talking about the levels. Here we are talking about L1, L2. L1 is, we saw it is within an area. If you compare this to OSPF, it is like a non-backbone area, regular areas.
Yeah.
So this advertisement of L1 will not go to the other area. Whereas L2 advertisement can go to other area. L1, L2 routers can be a member of both L1, so it can be a neighbor to both L1 and L2. It is like an ABR. So L1, L2 routers keep separate L1 and separate L2 database. This is what I was telling the other day. There will be two separate instances of neighborship and two separate database, one for L1 database and the one for L2 database. When a router advertises a route from border, means L1, L2, as L2, it will advertise only default route to L1. L2 will not advertise detailed route to L1. L2 will advertise only default route to the L1 router. If you don't understand, you need to see the demo video where I was showing on router 1, you will have a default route given by L1, L2 router, which is R2 on our topology. That's what this explains. This explains that L1, L2, though they have separate links in database, LSDB, they advertises only default route to L1 router. Did you understand that point? Let me show you with an example.
Yeah.
You see,
what I can
this router will not have a route to reach 3333 because it is coming from other area. For other area route, this L2 router will advertise only default route to L1. So using the default route, router 1 can now go to anywhere. R1 will not have detailed route if it is L1 only. This is
that
L1.
is one. Sorry.
Go ahead.
Yeah, I was asking that is when we do that. We issue the command of like ISIS circuit. Then I think you were saying something like it will be like a stop router, something like that.
Yeah, correct. Yes, stub. So the best advantage of ISIS is you don't need to configure stub. Stub is configured dynamically. Okay. Now going back, if you have a router with only L2, meaning it will not form any adjacency with L1, it's only between the different area routers. L2 router is like a backbone only router, area 0 only router. It will have only one database, which is L2. Addressing and routing. Area address is used to route between areas where system ID will not be considered. If you are routing between areas, what is considered is area ID. But system ID is used to route within an area. Area ID is not considered. ISIS routing logic. The level 1 router for destination address compares the area address to this area. If area ID is not equal, the local area ID and the destination area ID is not equal, it means it needs to go to the nearest ABR router. Correct, no? If the area ID is not matching, what does that mean? The packet belongs to different area. Do you understand the point?
Yes.
Yeah. So in the destination address means net ID, if the area ID of the local router and the area ID of the destination is not same, not equal, which means I don't need to see the system ID. I need to simply send it to the nearest L1, L2 router. Nearest. If you have multiple L1, L2 router, what is L1, L2 router? It's a border router, right?
Yeah.
It's a border router. So it needs to simply forward it to nearest L1, L2 router. If the area ID is same, what does that mean? I need to use a system ID to route the packet because the destination is in same area. Next. Now the nearest L1, L2 router receives the packet. The L1, L2 router for destination address compares the area. If not equal, then it will send using level 2 database to the other area. If it is equal, it will use L1 database and see the system ID's direction and forward the packet to that direction. So here we are seeing how L1 routes the packet and how L1, L2 routes the packet. L1 checks the area. If the area is not equal, it will send to the nearest L1, L2. In case if area ID is equal, which means I need to see the L1 database to forward the packet to the destination because the destination is in same area. It won't see L2 database, it will see only L1 database. Now on the L1, L2 router, if the destination area ID is not equal, which means it has to use the L2 database to see where the remote area is. If it is equal, it will use the L1 database, use the system ID and forward. So L1, L2 router will use both the database. L1 router will use only L1 database. Here is an example how the area IDs, system IDs or area IDs are unique within the area. System IDs are unique for every device. Okay, OSI area routing. Now, what path would X use to reach Y? What path will X use to reach Y, and what path will Y use to reach X? Try to find out your own answer. I'll wait.
Okay. Okay. S 1, 2, 1, 2, 3. As we use.
Okay, my answer here is already there. To go to X to Y, it is this line, green line. Why, you know?
Yeah.
10 plus 10 plus 10, 30, 30 plus 15 is 45. If we go the other routes, they are more than 45.
More, Exactly.
But while coming from Y to X, it is coming via this yellow line. You know why? For Y to reach X, the cost is easy from here. You know why? Because this is an L1 router. What will L1 router do if it needs to go to different area? If the area ID is not matching, what it will do? It will send to the nearest L1, L2. Yes or no? This router will send to the nearest L1. Nearest L1 is not this one. This is 15. The nearest L1 is this one, 10. Isn't it? Yes. So it will send the packet to this router. And this router will see, if I go like this, it is 10 plus 10 plus 10 plus 10, 40. If I come via this one, it is 30, 40, 50. So while going it goes like this, while coming it comes like this. You understood, no?
Yeah, I get the point.
So the story is the return traffic is not coming via the same path through which it went. It is called asynchronous path selection, asynchronous or asynchronous. The reason is
Okay.
that Y router will forward the packet to the nearest L1, L2 router using the default route because it's only L1 router, it's not L2 router.
But if one wants, you can maybe increase the interface bandwidth or reduce
No,
if
increase.
one wants to pass in the same direction like the
For that,
because
what
of the
you need to,
L11.
yeah, for that you need to make it as L1, L2.
Yeah,
Then it will come
yeah,
via the same path.
yeah,
Because it is
yeah. So
L1,
since
it will
it's
use the nearest L1, L2. This is the
L2,
nearest 10. This is not
yeah.
nearest 15. Okay, I think route leaking and all we'll see in the next class. We'll stop here.